Hello, good morning everyone. I am Dr. Dilip from Vali Rameshwar'S Ias Academy, and we are going to discuss a topic that is oil spills. So our institution is situated in Hyderabad, and our institutions provides both online and offline coaching. The offline coaching is affected due to the ongoing pandemic of COVID-19, and the online coaching is available, and you can avail it at an amount of 15,000 rupees. And you can also download the Vali's learning app on Play Store. You can reach us at www.valirameshwar'sacademy.com, and here are the phone numbers, so you can make avail of the coaching. So coming to the topic proper, definition. So what is an oil spill to begin with? An oil spill is the release of liquid petroleum hydrocarbon into the environment, especially in the marine ecosystem, due to human activity, and it is a form of pollution. So the oil can vary from one variety of oil to the other, and this variation of the oil is starting from the crude products, the crude oil, all the way to the vegetable oil or any other sort of oil. And basically whatever oil it is made up of the hydrocarbons, hydrogen and carbon and oxygen compounds. And the release of this petroleum hydrocarbons into the water will mean to the oil spill. And once this oil spill is happening, it predominantly happens because of human activity, and most of the oil spills are usually seen in the marine scenarios. And the term is usually given to marine oil spills, where oil is released into the ocean or coastal water, but oil spills may also occur on land. And what does this term oil means? So oil, the term, describes a broad range of hydrocarbon based substances, and these chemical compounds are composed of elements of hydrogen and carbon. This includes the substances that are commonly thought of as oil, such as crude oil, refined petroleum product, but also includes animal fats, vegetable oils, and so on. Each type of the oil has distinct physical features based upon the type of hydrocarbon chains that are present in the given oil. Then moving on, so from where do these oil spills happen, or from where do the oil spills come from? These oil spills can happen from where oil is used, that is anywhere from where the crude is refined or stored or used as fuel in manufacturing, and in all these areas there is a risk of oil spill happening. And also whenever the crude is being transported, or the petroleum products or these hydrocarbon compounds are transported from the place of generation or production to the place of refinery or refinement, and from there again to the markets, anywhere in this due process there can be oil spills and the accidents that happen during the extraction of oil. Example, the Deep Horizon incident. So whenever crude oil is being extracted from the oil rigs, using the oil rigs, there can be accidents in the oceans, and the release of crude can happen, thereby contaminating, leading to an oil spill. And also natural seeps of oil. Natural seeps means in nature itself, so because of the intense pressure of this natural gas and oil that is present buried deep in the surface of the earth, because of this pressure it slowly starts seeping into the water. So that is another reason, but most of the times you can see the man-made causes of this oil spills. So when we think of oil spills, we usually think of oil tankers spilling their cargo into oceans or seas and spill by accidents one way or the other into the oceans. However, this oil spilled on land at times can often reach lakes, rivers and wetlands, whereby which it can cause damage that is nothing but various types of pollution. And when oil is spilled in an aquatic environment, it can harm the organisms that live on around the water surface and those that live under the water. So basically whenever there is a water body, if this is the surface of the lake or water body, this oil pollution can affect the organisms that are present on the surface of the lake, and also the organisms that are present in the lake or the water body, because it is effectively cutting out the oxygen dissolution, because for oxygen to get dissolved into the water, it needs that the oxygen will come in contact with the water interface in the presence of sunlight. So if the oil spill is happening and oil is forming a fine layer on the interface of the air water, then the dissolution of oxygen is affected, thereby which having a detrimental effect on the organisms that are living inside these water bodies. The spilled oil can also damage parts of the food chain, including human food resources. So basically what is happening, whenever the oil is spilled on this surface, and also the oil can just turn into small parts or small quantities and can start falling from the surface into the bottom, whereby which it can contaminate the various organisms. Means various organisms can feed them, and through the food chain, that is nothing but one organism being eaten by the other organism, this transmission of this oil can take place, and subsequently, because all the food chains are interlinked, that is nothing but forming a food web, at one point or the other, these contaminated organisms can enter the food chain of humans, thereby which even human beings are affected. Then moving on, here in the image you can see after the aftermath of an oil spill, you can see various organisms that are affected and they are dead. Okay, different types of bivalve mollusks, echinodermata, that is the starfish, and all these organisms are also affected and they are dead. So the severity of the impact of an oil spill depends on the variety of factors, including characteristics of the oil itself. So here oil spill can occur. So we have seen that oil spill means oil can include various types of oil, starting from the crude oil, the bunker oil, and also the vegetable oil, kerosene, diesel, and all this. So these oils have varied physical and chemical properties, and this is because of the composition of this oil varies, and that is because of various types of hydrocarbon chains that are present in this oils, and because of the changing physical characteristics, they have different volatility or different ability to evaporate. So based upon the characteristics of the oil, if at all the oil that is leading to the oil spill is having high volatility, so what will happen? It will get evaporated, and thereby which the damage to the organisms that are present in the water will be limited. But if the oil that has been spilled has high viscosity, less volatile point, that is means it requires large amounts of energy to undergo change in transformation of phase from the liquid phase into gaseous phase. If that is the case, then they will remain for a longer period on the surface of water and also can contaminate the water, and thus it depends upon the type of oil. Then natural conditions such as water temperature and weather also influence the behavior of oil in an aquatic environment. So for an oil spill, if at all an oil spill has happened, so if you compare the oil spill that has happened in a colder area, that is in the colder water body near the Arctic, and if you compare the oil spill that has happened near the equator, the behavior of the oil spill will differ. So rate of evaporation of the volatile compounds will also vary because the temperature also varies. Then moving on, most oils tend to spread horizontally into a smooth and slippery surface which is called as slick on top of the water. So if at all you see the water body, this is the surface of water body and this is the water under the water. So what happens whenever the oil spill happens, the oil is going to come and it is going to settle as a thin layer on the surface of water, and this happens because usually the viscosity of oil, and also if you talk about the density of oil, is usually less than the water, and as the density of oil is usually less than the water, it tends to float on the surface of water, and whenever it is floating on the surface of water, it forms a thin fine layer which can be called as the oil slick. And we have seen that is because of the formation of oil slick itself, it is cutting down the oxygen dissolution capability, thereby which impeding oxygen supply to various organisms that are present in the water bodies. Then the factors which affect the ability of an oil spill to spread includes the surface tension, specific gravity, and viscosity. As we have already seen, if the oil spilled whatever oil that has been spilled is having high viscosity. So what does viscosity mean? Means the thickness. So if that oil is very thick, in a simple sense for you to understand, what will happen? The oil spill will not spread further. It will be contained. It will be in a fixed place because of the viscous nature. It doesn't tend to move. And coming to specific gravity, if at all the specific gravity of a substance is high, then again it will also not tend to move on the water surface. It is going to be present suspended at one place or the other. And the other thing is the surface tension. If the surface tension of a liquid is high, again what will happen? So it will retain in one place. It doesn't spread. So if we compare two types of oils, one that is having low surface tension, low specific gravity and low viscosity. So what happens when all these conditions are met? The oil is free. It doesn't have significant cohesive forces and it tends to get distributed. It keeps on moving with the movement of waves. But if you compare an oil which is having high surface tension, high specific gravity and high viscosity, it will remain at a single place. It will not keep on moving. So the extent of spread of oil spill is going to be determined by these three factors, that is surface tension, specific gravity and viscosity. Then moving on to the next thing, what will happen after an oil has been spilled in the ocean or on the land? So if you talk about the fate of spilled oil, so once oil is spilled, so natural actions are always at work in the aquatic environments. So natural actions, we'll see what are those natural actions, and these natural actions by themselves, they tend to reduce the severity of an oil spill. That is because nature works in a way by which it will try to disintegrate or break the oil spill into smaller components, by which effectively removing the problem of oil spill. But it is going to have a significant effect and it is going to take significant amount of time for this process to take place. So in nature, what are the various processes that take place? If you see, that will include weathering, evaporation, oxidation, biodegradation and emulsification. These are the various things that happen once oil is spilled into the nature. So we'll talk about the first thing, weathering. So weathering is nothing but breaking down of a complex substance into simpler substances. So once oil spill has happened, you see, in a series of physical and chemical changes that cause spilled oil to break down and become heavier than water. So the wave action may result in natural dispersion, breaking a slick into droplets which are then distributed vertically throughout the water column. These droplets can also form a secondary slick or thin film on the surface of water. So if at all you see, once an oil spill is happening, so assume again this is the surface and oil has deposited on the surface of the water. So because of the movement of the waves keep on to move. What will happen over a period of time? These oil tends to break down into smaller components, and that is nothing but breaking down is called weathering. Once it breaks down into smaller components, what will happen is they will tend to form small parts and they will be moving down from the surface into the bottom as suspended particles, and further then the bacterial action will take place and it will further disintegrate. So this process is called the weathering process. Then coming to the next thing, evaporation. So as we have already seen, in whatever oil that has been spilled, there may be few components which have high volatility rate. So if at all those compounds have high volatility rate, what happens is they undergo faster evaporation. So once they undergo faster evaporation, what is happening? They will be a risk of explosion. So whenever a gas undergoes faster evaporation, it will tend to move to larger area, and in case by the heat, by the sunlight, it will tend to an explosion. And if you see here, this evaporation occurs when the lighter or more volatile substance within the oil mixture become vapors and leave the surface of the water. This process leaves behind the heavier components of the oil, which may undergo further weathering or may sink to the bottom of the ocean floor. Spills of lighter refined products such as kerosene and gasoline contain a higher proportion of flammable components known as light ends. So if at all you take gasoline and kerosene, they will undergo easy evaporation, given that the latent heat of vaporization of these substances is low, and thereby which the phase change occurs much faster, and once they are turning into a gaseous vapor, they will tend to get easily distributed. These may evaporate within a few hours, causing minimal harm to the aquatic environment, whereas heavier oils, that is vegetable oils and animal fats, leave a thicker, more viscous residue. These types of oils are less likely to evaporate. So the lighter the oils, the more chance they will undergo evaporation. Then coming to the next thing, that is oxidation. So whenever any substance that is exposed to oxygen will eventually undergo oxidation. So in nature, what is happening whenever oil spill occurs, we'll see when oil contacts with the water and oxygen combines with the oil hydrocarbons to produce water soluble compounds. This process affects oil slicks mostly around their edges. So here, why edges? So assume this is the water surface and here this is the oil spill. So this oil spill will be again having contact with water on all the edges and also from the bottom. So near the edges of this oil spill, so you can see it will come in contact with oxygen. So there is more chance that oxidation is going to occur at this plane, and the thick slicks may only partially oxidize, forming tar balls. Means they will undergo oxidation and form thick, large, viscous substances like spear-shaped substances which will get suspended in the water. These dense, sticky ball spears may linger in the environment, washing up on shorelines long after a spill. Then coming to the next thing after oxidation, it is biodegradation. So here biodegradation, as we have seen, is because of microorganisms such as bacteria which feed on oil hydrocarbons. A wide range of microorganisms is required for a significant reduction of oil. So we will see in the class, in the coming slides, we are going to discuss about various types of microorganisms which are helpful in this biodegradation process. To sustain the biodegradation, nutrients such as nitrogen and phosphorus are sometimes added to water to encourage the microorganisms to grow and reproduce. And biodegradation tend to work best in warm water environments. Then emulsification. So emulsification is nothing but the breakdown of fats is called emulsification. So here you have to understand what is an emulsion. If you talk about an emulsion, emulsion is a mixture of two different types of liquids. So here it is a process that forms emulsions, which are mixtures of small droplets of oil and water. And emulsions are formed by wave actions and they greatly hamper weathering and cleanup processes. So if you see, emulsions here can be two types because we are going to take only two liquids, that is, one is oil and the other is water. So two types of emulsions can be formed. One is oil in water emulsion, oil in water, and the other is water in oil emulsion. So why these two types of emulsions are formed? So in the abundance of water, what will happen? Oil in water emulsion will be formed, and if at all water is trapped in the oil, then you can come across the water in oil type of emulsion. So here what is happening, the two types of emulsions exist, that is water in oil and oil in water. Water in oil emulsions are frequently called chocolate mousse. So here you have to remember, so if at all it is a water in oil, that is water is trapped in the oil, this type of emulsion is called chocolate mousse, and they are formed when strong wave action causes water to become trapped inside the viscous oil. Chocolate mousse emulsions may linger in the environment for months or even years, whereas oil and water emulsions cause oil to sink and disappear from the surface, giving the visual illusion that it is gone and threat to the environment has ended. So then moving on, so if you see this image here, you can clearly see that what is happening because of the sun. You can see evaporation, oxidation when coming in contact with oxygen in the environment, and it is spreading both sides because of the wind. And you can see emulsification because of the movement of waves. What is happening? The oil is getting mixed with water, and sometimes water is getting trapped in the oil, thereby which leading to two types of emulsions, and biodegradation by various types of microorganisms, that is dispersion, breaking down larger ones into smaller one, and because of the weight sometimes sedimentation can occur. So if you see, these natural actions occur differently in freshwater versus marine environments. Freshwater environments impacts can be more severe because water movement is minimized in these habitats. So here, whenever an oil spill is happening on the surface, because of the intense movement of waves in the marine ecosystems, what is happening? The oil spill tends to spread. At the same time, there is a chance of occurrence of emulsification and biodegradation and dispersion at a larger scale. So the impact that is caused by the oil spill in marine environments may be less when compared with the effects that you can see in freshwater ecosystems, whereby which the movement of the waves or wave formation is absent or minimal, where emulsification and other process, natural process of breakdown of this oil spills is not often seen. In standing water bodies, oil tends to pool and can remain in the environment for longer periods of time. In flowing streams and river, oil tends to collect on plants and grasses growing on the banks. And also, oil can also interact with the sediment at the bottom of the freshwater bodies, affecting organisms that live or feed on the sediments. So what is happening? You can see the sedimentation. If it is an freshwater ecosystem, so here the organisms, this zone will be called as benthos, and the organisms that live here are called benthic organisms, benthic. And here, if at all it is further more deep, you have the profundal zone. So all this you will learn in ecology. So what is happening? These organisms which will feed on the sediments that are falling from the upper segments of the water will tend to feed, and thereby which these organisms living here will be affected because of the oil spill. Then moving on, what is the effect on the living organisms? So here if you see, some toxic substances in an oil spill may evaporate quickly. We have seen the volatile substances evaporate quickly, and therefore plant and animal and human exposure to the most toxic substances are reduced within time and are usually limited to the initial spill area. So because of evaporation, if this is an area where the oil spill has happened, this oil will get evaporated because it is volatile. Whatever volatile components will get evaporated, and thereby which reducing the effect of oil spill on these organisms. And whatever oil residue that has been left is definitely going to have a negative impact on this organism. So you can see, although some organisms may be seriously injured or killed very soon after the contact with the oil in a spill, non-lethal toxic effects can be more subtle and often long lasting. So here you have to understand, in the initial contact itself, some organisms may not sustain and they may die. Because so why they will die? Because this oil spill may form a thick layer in the water. These organisms may get engulfed or totally covered up with the oil spill. So by which what is happening, their respiratory apparatus or the organs may be impeded in taking oxygen from the water into their body. And once oxygen impairment has been reached, the organisms tend to die. And apart from this, once if at all the organism is not getting killed because of the oil spill, these oil spills will lead to formation of minute particles which may be engulfed, which may enter the respiratory system, liver, nervous system of these organisms, and they may cause significant damage, not killing the organism though, but totally affecting its life. And these effects will be long lasting. Then for example, if you see, aquatic life on reefs and shorelines is at risk of being smothered by oil that washes ashore. So if you see the reefs, that is the coral reefs. So coral reefs are usually present in large quantities in shallow waters. They have been also noted in the deep waters. But these corals which require the proper sunlight, so they are present in the photosynthetic zone, that is especially euphotic zone, where the sunlight is available for them to perform photosynthesis. But in case of an oil spill where a slick is formed on the surface, effectively preventing the sunlight to penetrate into the superficial layers of the water, where photosynthetic organisms such as the corals, the organisms zooxanthellae which are present in the corals, cannot perform photosynthesis, thereby which leading to damage of the corals itself. That is the meaning of smothered by oil. Means whatever oil is washing ashore, it will form layers, thereby which preventing effective penetration of sunlight. It can also be poisoned slowly by long-term exposure to oil trapped in shallow water on the beaches. So these components may kill the photosynthetic pigment. So both petroleum and non-petroleum oil can affect the environment surrounding an oil spill. So here, what is the meaning of petroleum? Means, you know, various types of oils that are derived from crude, like example, the bunker oil, furnace oil, diesel, petroleum, all these are petroleum oils. Then what about the non-petroleum oils? Non-petroleum oil include your vegetable oil, animal fat, and all these sort of things. And all types of oil share chemical and physical properties that produce similar effects on the environment. In some cases, non-petroleum oil spills can produce more harmful effects than petroleum oil spills. So why is this case? Why non-petroleum oil spills can be more dangerous than the petroleum oil spills? That is because if you talk about the non-petroleum oil spills, they do not have easy evaporative nature. That is, their volatility nature is very less compared with that of the petroleum oil spills. Petroleum oil spills tend to have low volatility point, and thereby which they evaporate much faster. Once they evaporate, whatever residue is left, that will be less compared with that of the non-petroleum, because they do not evaporate and they tend to stay longer periods of time in the environment. Then moving on, the aquatic environments are made up of complex interrelations between plant and animal species and their physical environment. Harm to this physical environment will often lead to harm to one or more species in the food chain, which may lead to damage of other species further up the chain. So we have already discussed this earlier. So when certain organism is affected, so assume a small plant species, aquatic plant species, aquatic plant is affected by the oil spill. So what is happening? This affected plant, damaged plant, can be consumed by other organism, and this negative impact of the oil is getting transferred from the plant to the primary consumer, from there to the secondary consumer, and from there to the tertiary consumer. So what is happening? It will lead to harm to one or more species in the food chain and ultimately lead to the damage of other species further up the chain. So example, if you take like the Minamata disease, what is happening in Minamata disease of Japan? So the mercury poisoning has happened. Methyl mercury was found in large quantities in the water, which was consumed by the zooplankton, and once the zooplankton has consumed the methyl mercury, the concentration of methyl mercury in the bodies of zooplankton has increased. Then the fish consumed large quantities of zooplankton, leading to biomagnification, means the concentration of the methyl mercury has increased in fishes, and once humans have consumed the fish, the amount of methyl mercury from the fish has been transferred to human. So moving up the food chain, what is happening? The damage that is caused by the toxicity of the oil spill is getting transferred up the food chain. And here, where an organism spends most of its time in open water near coastal areas or on the shoreline, will determine the effects of oil spill is likely to have on the organisms. So if at all you talk about the organisms that usually lives in open waters. Open waters means in between the water body, too far away from the shore. So if an organism is present far away from shore, if there is an oil spill in that area, what will happen? The organism can go deep. Like if you talk about the whales or any large fish, if there is an oil spill, they do not get affected because they will go deep into the water. But if you talk about the organisms that tend to live near the shores, so because of the movement of waves, what is happening? The oil spill is getting pushed and it is coming to the shoreline. And these organisms which live at the shoreline do not have any other option, but they are getting affected negatively because of the oil spill. And in open waters, fish and whales have the ability to swim away from the spill by going deeper into the water and further out of the sea, reducing the likelihood that they will be harmed by even a major spill. Aquatic organisms or animals that generally live closer to the shore, such as turtles, seals and dolphins, risk contamination by oil that washes onto the beaches or by consuming oil contaminated prey. So sometimes what happens, whenever these organisms consume the oil contaminated prey, they die because of the toxic effects. That is one thing. And second thing, once they consume, the food may not be palatable, that is the taste of the food may be varied, and these organisms may stop feeding because they do not like the taste, and they may go into starvation and subsequently die also. In shallow waters, oil may harm sea grasses and kelp beds, which are used for food, shelter and nesting sites of many different species. So this sea grasses and kelp beds are nothing but the primary producers in shallow water. Primary producers means the organisms or the substances, the organisms which perform photosynthesis and fix the sunlight into chemical energy by producing the food for the primary consumers. Even those get affected. Then if here is an image of a bird, you can see that its plumage, that is the feathers, are entirely covered with the oil spill, and once that is there, it cannot fly because what is happening, this oil is very sticky, the plumage entirely is stuck and the bird cannot fly. And over a period of time, even you can see the nostrils of the bird. So these nostrils may be clogged and it cannot breathe. Its oil, if it enters into its body, it is going to have a devastating effect on the various vital systems in the body of this bird, thereby which killing the poor organism. So here we are going to talk about the effect on birds and animals. So if you see the effect, an oil spill can harm birds and mammals in several ways: direct physical contact, toxic contamination, destruction of food sources and habitat, and also lead to reproductive problems of these organisms. So first, if you talk about the physical contact, what type of problems will be there? So as we have already seen, when fur or feathers come into contact with oil, they get matted down. So once you can see, if at all a bird is wet, do you think that the bird can fly? Definitely not. So it tries to dry its feathers before it starts its flight. But here it cannot even dry it up because it is sticky, effectively preventing the bird from flight. This matting causes fur and feathers to lose their insulating properties, placing animals at risk of freezing to death. So if at all you talk about the temperatures in the oceans, they will be freezing, okay, so near zero, even less than zero. And at these temperatures, whenever they come in contact for catching some fish or anything, they come onto the surface. If they are stuck in the oil spill, they tend to die. For birds, the risk of drowning increases as the complex structure of their feathers that allows them to float or to fly becomes damaged. Then toxic contamination. So coming in contact with these toxic substances is nothing but toxic contamination. Some species are susceptible to the toxic effects of inhaled oil vapors. So whenever there is an oil spill, automatically the volatile substances that are present in the spill will convert into vapor. And once these organisms, the birds that are flying above the oil spill, when they inhale these toxic gases, they may also get affected. These oil vapors can cause damage to animals' central nervous system, liver and lungs. Animals are also at risk from ingestion of oil, which can reduce the animal's ability to eat or digest its food by damaging cells in the intestinal tract. So here you have to understand that this oil is damaging the vital organs of the birds and animals. Then moving on, the next slide, here you can see how the bird is in pain because of the bird getting trapped in a oil spill. So here you see destruction of food resources and habitats. So what is happening whenever there is an oil spill? That oil spill is going to even affect the habitat, means the place of residence of these birds and animals, and also it is going to affect the food resources. As I have already discussed, this oil spill will effectively cut off the sunlight that is entering the water. So when sunlight is affected, the organisms that perform photosynthesis do not perform the photosynthesis. When there is no food, the food resources of these animals and birds will be adversely affected. So here you can see even species which are not directly in contact with the oil can be harmed by a spill. Predators that consume contaminated prey can be exposed to oil through ingestion. And because oil contamination gives fish and other animals unpleasant tastes and smells, predators will sometimes refuse to eat their prey and will begin to starve. When they don't like the taste, they will rather go into starvation and they will die. Sometimes a local population of prey organisms is destroyed, leaving no food resources for predators. So once the food resources are exhausted, automatically the organisms which are dependent on those food resources tend to die. Depending on the environmental conditions, the spilled oil may linger in the environment for longer periods of time, adding to detrimental effects. So the longer the oil spill is present, more the detrimental effects of the oil spill on the surrounding environment. In calm water conditions, oil that interacts with rocks or sediments can remain in the environment indefinitely. In calm water means where the movement of the water is not happening. That is, especially if you see a closed water body, that is a lake or any other thing, what happens is no movement, and because of no movement, no natural disintegration process, that is withering process is affected, evaporation is affected, at the same time emulsification is affected, which are the natural process of by which the oil spills will get degraded. Then reproductive problems. So here you have to understand a reproductive problem, that is nothing but birds especially reproduced by laying eggs. So if we talk about the eggs also do breathe. So as a matter of fact, you people should know that eggs also do breathe. So the eggshell, hard eggshell, has many number of pores. So through these pores, the developing embryo that is present in the egg tends to breathe. And once these eggs, if at all assume this oil is, if this is an egg, this oil is covering up the egg totally, what will happen? It will prevent the gaseous exchange, that is entry of fresh oxygen and release of carbon dioxide from the egg is getting affected. And when that is getting affected, what is happening? The embryo inside the egg shell dies, thereby which affecting the reproductive activity of the birds. So you can see oil can be transferred from birds' plumage to the eggs as they are hatching. So once the bird lays egg, it goes, feeds and comes and again tries to incubate the eggs. And when it does, sometimes it can transfer the bird's plumage, that is the feathers can transfer the oil, and oil can smother eggs by sealing pores in the eggs and preventing eggs gaseous exchanges. So scientists have also observed developmental effects in the bird embryos that were exposed to oil. Means the embryo is not developing properly. So if the embryo doesn't develop properly, the bird will die, young bird will die. And the number of breeding animals and their nesting habitats can be reduced by the spill. Long-term reproductive problems have also been shown in some studies in animals that have been exposed to oil. So these are the detrimental effects on the organism. So here this is an image where you can see that it is depicting the mangrove trees. So in ecology we'll be coming across what are mangrove trees and what are the unique characters, and here you can see that the mangrove trees roots are totally dredged. So maybe the water column would have come till here. So that is the reason when water has moved, it has, that water which was having the oil spill has covered up the total trunks and roots of this mangrove. So what is happening whenever that cover up is happening? This oil is also detrimental to the mangrove trees. So here you can see spilled oil immediately begins to move and weather, breaking down and changing its physical and chemical properties. As this process occurs, the oil threatens surface resources and wide range of subsurface aquatic organisms linked in a complex food chain. Many different types of aquatic habitats exist with varied sensitivities to harmful effects of oil contamination and different abilities to recuperate with oil spills. Means not all organisms are capable of addressing or ability to withstand the oil spill. Different organisms respond in a different way. In some cases, the habitats and populations can recover quickly. In other environments, however, recovery from persistent and stranded oil may take years. So here you can see that oil spill is going to have long-term implications. These detrimental effects are caused by both petroleum and non-petroleum oil. And moving on, controlling oil spills. So once the unfortunate, that is what that shouldn't have occurred, that is the oil spill, if it has happened, then what are the steps, what are the measures to be taken to limit the effect and to recover the oil? So that is nothing but controlling oil spills. So if you see, two major steps involved in controlling oil spills are, so once here controlling oil spills means it doesn't mean that control or preventing the oil spill to happen, but rather it means once the spill has happened, how to control the spill from spreading. So that includes the first one, that is containment, that is limiting the spread of oil spill, and the second one is recovery. So once you contain or limit the spread of oil spill, you will try to recover the oil. Okay, and why recovery? So one thing is, if at all you can utilize whatever oil that has been recovered, that can be done, or else for disposal, because it cannot be left in the nature as itself, because it is very toxic. Then here you can see the image responding to oil spills at sea. We'll come to that later. And containment, talking about to containment in particular, when an oil spill occurs on water, it is critical to contain the spill as quickly as possible in order to minimize the danger and potential damage to persons, property and natural resources. So the containment equipment is used to restrict the spread of oil and allow its recovery, removal or dispersal. The most common type of equipment used in control for the spread of oils floating barriers called booms. So here if you see why containment is needed, why do we need to contain the spread of an oil spill, that is important. So here, if at all you spend significant amount of time not being able to contain the spread of oil spill, the oil spill will tend to spread to large areas because of the movement of the waves in the ocean, and it can reach the shore, affecting various types of organisms in a negative way. And at the same time, as you can see, the volatile substances, whatever that are present, can also undergo evaporation, and there may be situations where flammability of the oil can happen and it can catch fire. And this oil spill can slowly break down and enter into the water below, and which can be ingested by various organisms and affecting them in a negative manner. So to prevent all that from happening, what is done is containment should be done as fast as possible. So what are the methods by which containment can be done? So one of the most common method is by booms. So what are these booms? So containment booms are used to control the spread of oil, to reduce the possibility of polluting shorelines and other resources, as well as concentrate oil in a thicker surface layers, making recovery easier. In addition, booms may be used to divert and channel oil slicks along desired paths, making them easier to remove from the surface of water. So here you can see responding to oil spills at sea. So booms, as you can see, are nothing but floating structures that are put whenever there is an oil spill or across the oil spill, so that because the oil will be floating on the surface of the water, to restrict the spread of this oil spill, these booms, which are filled with air but they are having certain weight so that they can remain suspended in the water, will be put around the oil spill, which will limit the spread of this oil spill. And other modalities, dispersion, we will deal about later. Burning and skimming will come about subsequently. As you can see here, this is the image of a boom. So what is happening? This boom is a air-filled inflatable bag, tube-like things, by which what is happening when there is an oil spill, they are putting these booms around the oil spill to prevent the spread of oil. And once they are preventing the spread, the concentration of the oil or the thickness of the oil layer that is formed will increase. So once the thickness is more, what is happening? Effective recovery will be easier. So if there is a thin layer of oil on the water, recovery of oil will be difficult. But if at all the oil layer is thicker enough, the recovery will be made easier. So these are nothing but the booms. Then other barriers, that is nothing but improvised booms. So if at all there is an accidental oil spill, you can't wait for the government or to the agencies to bring these booms and use them to restrict the spread of oil. But rather, here improvised booms means, as you can see, when an oil spill occurs and no containment equipment is available, barriers can be improvised from whatever materials that are at hand. So that will include, most often used as temporary measures to hold or divert the oil until more sophisticated equipment arrives. Improvised booms can be an effective way to deal with oil spills, particularly in calm water such as streams, slow moving rivers, or sheltered bays and inlets. So from what this improvised booms are made? So these improvised booms can be made from materials such as wood, plastic pipes, inflated fire hoses, automobile tires, and empty oil drums. So all these the main aim is creating a barrier around the oil spill, thereby which effectively limiting the spread of this oil spill. Okay, so they can be as simple as a broad board placed across the surface of slow moving stream, or a berm built by bulldozers pushing a wall of sand from the beach to divert oil from sensitive sections of the shoreline. Then moving on, we have seen the containment. Then comes the recovery oil. So once you have contained this oil, that is preventing the spread of oil to large sections in the water, the next thing what you can do is recovering the oil that has been spilled out. Once an oil spill has been contained, efforts to remove the oil from the water can begin. 3 different types of equipments, that is booms, skimmers and sorbents, are commonly used to recover oil from the surface. We will see one by one. What are these booms? We have already seen these booms. When used in recovering oil, booms are supported by horizontal arm extending directly off one or both sides of a vessel, sailing through the heaviest sections of spill at low speeds. A vessel scoops the oil and traps in between the angle of boom and the vessel's hull. So what is happening? If you talk for that matter, a ship is there. A big ship is there. So this big ship, this front part, what you can see, will be called as hull. This is called as hull of the ship, this hull. So if an oil spill is there, this oil spill is going like this horizontally, and this is the heavier section. So this hull will be directed in such a way that it will be going in perpendicular way, by which 2 sections of the oil spill will be formed, which can be taken off or lifted and trapped in between as the vessel scoops, such as the angle of the boom and the vessel's hull is present. So there is an angle by which the scooping will take place. So in another variation, a boom is moved at the end points of a rigid arm extended from the vessel, forming a U or J. Here you can see U or J shaped pocket in which oil can collect. In either case, the trapped oil can be pumped out by holding tanks and returned to shore for proper disposal or recycling. So here, recovery of oil, what it is being done, a total section of a boom is laid, and the ship or a vessel using its hull is going to move in the direction of the oil, and it is going to trap the oil. And once trapping of oil is done, this water can be pumped. Again, they are going to close it, and the water that is mixed with the oil from here is pumped onto the shore, where it can be segregated. If it is used, if it is worthy, it can be used, or it can be disposed of. Then comes the next thing is skimmers. So what is a skimmer? A skimmer is a device for recovery of spilled oil from water surface. Skimmers may be self-propelled and may be used from shore or operated from vessels. The efficiency of skimmers depends on weather conditions. In moderately rough and choppy waters, skimmers tend to recover more water than oil. So here is a diagram or a picture of a skimmer. So what the skimmer is doing, it is continuously a rotating type of device where it will pull the oil from the surface layers of water into itself. So the skimmer, what it does is, when there is relatively calm in the water, it is effectively taking or trying to recover large quantities of oil. But as the water becomes choppy, or when there are a lot of waves, what will happen? The oil and water will keep on mixing, and as a resultant, this skimmer will not function properly, as it takes in large amounts of water instead of oil that it can collect. Then surface measures used to contain oil spillages. So one thing is booms. Here you can see U-shaped structures by 2 vessels. Okay, that is nothing but the contained oil. And here the boom, if you see the structure, it is having a float which is inflated with water, water draught or weight which is attached to it, so that it will not be simply pushed away by waves. And here if you see, this is a skimmer, it is doing the activity of skimming. So once here what is happening, oil is pumped to collection sump, okay, and the brushes will catch hold of the oil. And another thing is dispersion here, where chemicals break down the oil, okay. And another thing is fire retardant boom, okay. So this boom is capable that it will not burn away even if this oil, whatever that is collected, is set to fire. So you can see an example of the oil spill. Then next comes sorbents. So these are nothing but they work on the principle of both adsorption and absorption. Adsorption and absorption. So what is the difference between adsorption and absorption? So adsorption is something that if a material is there, if some substance that is present, if we say that it is undergoing adsorption, it means that substance is getting present or it is getting stuck onto the surface of the substance, but it is not going deep into the surface. It is only binding or it is only attaching to the surface of the substance. Then that procedure is called adsorption. Whereas absorption, what is happening? Into the substance enters deep into the absorbing body. Like if you talk about a sponge, a simple sponge. So if you take a simple sponge, what happens? You dip it into the water. So water is not only being adhered to the surface of the sponge, but the water is being taken up deep into the sponge. That it is called absorption. Adsorption, if you talk about activated charcoal, where only on the surface some other substance will come and get attached to, that is called adsorption. So here basically this sorbents, if you see, sorbents are materials that soak up liquids and they can be used to recover oil through mechanisms of absorption and adsorption or both. So absorbents allow oil to penetrate into pore spaces in the material they are made of, while adsorbents attract oil to their surfaces but do not allow it to penetrate into their material. So adsorbent only onto the surface, the oil will be attached. Absorption, oil will enter into the substance of the deep into the substance. That is the difference between adsorption and absorption. To be useful in combating oil spills, sorbents need to be both oleophilic and hydrophobic. So here you have to understand two words. For any material to be used as a sorbent, we have two rules. What are the two rules? We will see one rule is to be oleophilic and the other is hydrophobic. So whenever there is an oil spill, you are going to use the sorbents to absorb or adsorb what? That is oil. So if you throw into an oil spill, if the sorbent material is absorbing or adsorbing water, will it be useful? Definitely not. So oleophilic means oil loving and hydrophobic means water hating. So any material that doesn't absorb or adsorb water, but rather it absorbs or adsorbs oil, can be used as a sorbent. That is the meaning of oleophilic and hydrophobic. Although they may be used as a sole cleanup method in small spills, sorbents are most often used to remove final traces of oil or in areas that cannot be reached by skimmers. So usually if at all there is a large oil spill, skimmers are needed. But if there are smaller oil spills, you can do up with, the cleanup process can be done with sorbents. Once sorbents have been used to recover oil, they must be removed from the water and properly disposed of on land or cleaned for reuse. Any oil that is removed from the sorbent materials must also be properly disposed of or recycled. Then moving on, here responding to oil spills onshore. So whatever we have seen, the skimmers and everything, it is in the open waters near the shore. If it all means oil spill has happened near the shore or oil spill that has happened in the open seas has been pushed onto the shore, what will happen? So shoreline flushing and washing. So with high pressurized water pipes, the people will flush the shoreline. Because why? What is the problem with the shoreline? The shoreline, if at all you talk in terms of ecology, the shoreline is a transition phase between two different types of ecosystems. That is the marine ecosystem. If you move from the shore into the water, it is a marine ecosystem. So it supports varied type of organisms. And if you move from the shore onto the land, you can find a terrestrial ecosystem. So this transition zone will support a large amount of varied biodiversity, that is different types of organisms are supported. If at all you don't clean up this shore in a proper way, a varied type of biodiversity will be lost. Means many different species of organisms will tend to die because of oil spill. That is what this shoreline should be flushed, or that it should be washed. So water hoses can rinse oil from the shoreline into water where it can be moved easily and collected. That is one way. Second thing is booms, that is floating. You can see this one is a boom. Long floating interconnected barriers are used to minimize the spread of spilled oil. Then vacuums. Third one is vacuum. So using a vacuum, here you can see this is a vacuum suction. This suction can be used to suck the oil from the shoreline and the surfaces. Then sorbents, we have already seen sorbents. So then shoreline cleaner and degradation agents. So they are going to use some oil eating bacteria or any other substance, and burning. So a fire resistant boom is put around the oil and it is set fire. But though it causes a varied amount of air pollution, it is used at times. Then manual removal, as you can see here, manually dredging, and mechanical removal by using machines, by bulldozing and other. This oil spills can be removed from the onshore. So here the primary tools used to respond to oil spills are mechanical containment, recovery and cleanup equipment. Such equipment includes a variety of booms, barriers and skimmers, as well as natural and synthetic sorbent materials. A key to effectively combating spilled oil is careful selection and proper use of equipment and materials most suited for the oil and the conditions at the spill site. So for every oil spill you cannot use the same type of methods. So simply you cannot think that, okay, oil spill has happened, I will use the sorbents. So sorbents are only used for a tiny spill, okay? And you can also see that most spill response equipment and materials are greatly affected by such factors as conditions at sea, water currents and wind. Damage to spill contaminated shorelines and dangers to other threatened areas can be reduced by timely and proper use of containment and recovery equipment.